A mysterious portal discovered on Mars. So, what it could be? Alien life?
Okay,
Let's
let's
deep
unpack
dive.
this. NASA just shared this image, right? A huge hole on Mars, like 300 feet wide.
Hmm.
And they're actually calling it a portal. I mean, your mind just races, doesn't it? What could that actually be?
It definitely does. It grabs your attention straight away. And what's really interesting is that NASA themselves, they're pointing out how significant it could be.
Right.
It's not just some weird rock formation. They're actively saying, hey, this might be an opening, like an opening to caves, extensive systems underground.
Exactly. So for this deep dive, we're going to go, a bit beyond just the headline. We've got the NASA info, their astronomy picture of the day release, plus some stuff from the U.S. Geological Survey.
Right. The USGS data is key here, too.
Yeah. And for everyone listening, our goal is to really dig into what this might mean,
Yeah.
especially for the hunt for life out there.
Okay, so let's start with the picture itself, the image. It wasn't taken yesterday, actually. It's from 2017.
Oh, right.
Yeah, captured by the Mars Reconnaissance Orbiter. NASA just shared it this past Sunday as their picture of the day.
And what does it show exactly?
Well, you see this area on Mars, and it's kind of dotted with these depressions, almost like Swiss cheese or maybe sinkholes.
Uh-huh.
But then, bang, in the upper right corner, there's this one. And it's not small. We're talking roughly 328 feet across.
Wow.
A really noticeable hole, and it sits inside this bigger sort of circular dip in the ground.
In NASA's language. Pretty interesting, right? Using the word portals.
Yeah, that stood out to me too. They specifically said these holes are of particular interest because they might be portals to lower levels that extend into expansive underground caves.
Portal, it just conjures up images, doesn't it? Like a doorway somewhere else entirely.
It really does. And you have to think about why underground is so interesting on Mars. The surface. It's incredibly harsh.
Right, the atmosphere is super thin.
Exactly. Barely any protection from cosmic rays, solar radiation. It's constantly bombarded.
Yeah.
Plus, the temperature swings are wild, mostly extremely cold.
And liquid water on the surface. Pretty much a no-go.
Virtually non-existent. Yeah. So the surface is, well, it's tough.
So the idea that underneath all that hostility, you could have these, networks of caves.
Yeah.
Naturally shielded.
That's the potential game changer.
Yeah, because we've often talked about, microbes maybe living in frozen oceans on Europa or Enceladus. That's been a big focus.
Subsurface oceans.
But this feels different, like maybe more complex environments could exist. It kind of raises the stakes, doesn't it?
It definitely broadens the search parameters. These potential caves, they could offer stability, more consistent temperatures, maybe.
Okay.
Protection from that relentless radiation is huge. And there's the possibility of trapped water ice, maybe even liquid water in spots warmed by geothermal heat, perhaps.
Right, if there's any heat left down there.
Conditions the surface just can't provide. And think about Earth. We find complex ecosystems deep underground in caves, totally cut off from sunlight.
Life finds a way, sort of thing.
It makes you wonder, could something similar have happened or even be happening on Mars?
And this isn't just NASA seeing one weird hole, is it? You mentioned the USGS.
No, not at all. The U.S. Geological Survey, specifically their Astrogeology Science Center, they've been mapping these things. And they've cataloged over 1,000 potential cave entrances. Skylights, basically, on Mars.
1,000. Okay, so this is potentially a widespread thing, not just an oddity.
That's what the data suggests. Yeah, it points towards this possibility of, pretty extensive underground systems, not just little isolated pockets.
But we don't know for sure how big or deep they are.
Exactly. That's the big question mark. We see the entrances, these skylights,
Right.
but the actual extent, the interconnectivity of these potential cave networks, that's still largely unknown territory, like finding lots of rabbit holes, but you don't know if they connect into a huge warren or just end.
Still, finding the holes is the first step. And you mentioned something earlier, lava tubes. How do they fit into this?
Ah, yes. Lava tubes are considered prime candidates for these structures. Billions of years ago, Mars was much more volcanically active.
Right, like Earth was.
Exactly. You had massive lava flows. Sometimes the top layer of the lava would cool and harden, forming a crust.
Okay.
But underneath, the molten lava kept flowing, like a river inside a pipe. Eventually, the eruption stops, the lava drains out.
And leaves behind a tunnel, a tube.
Precisely. A natural cave, essentially. And the key thing is, these would have formed very early in Mars's history.
So they'd be ancient shelters?
Potentially. Shelter formed before Mars lost most of its atmosphere and magnetic field, back when conditions might have been a bit more conducive to life starting.
Ah, okay. So they could have offered protection as the surface got progressively worse.
That's the idea. Protection from the cooling climate, the thinning air, and especially that increasing radiation. If life ever did get started on early Mars, these tubes would have been, well, pretty ideal natural bunkers. A stable place to potentially survive over geological time.
Okay, so let's pull this together. We've got this striking image of a big potential portal. We've got the USGS mapping over 1,000 similar features.
Potential features.
Right, potential features. And we have this very plausible geological explanation about ancient lava tubes. It really feels like this is pushing NASA and, the whole scientific community to look underground more seriously.
Absolutely. The focus is definitely shifting, or at least intensifying, towards these subterranean possibilities.
It just makes sense, doesn't it?
It's logical. If life ever existed, or maybe even still exists in some microbial form, the underground offers the best odds for survival, based on what we know. The surface is just incredibly challenging.
And this isn't just about satisfying curiosity, right? This has real implications for, future missions.
Right.
Where we send robots, maybe even people eventually.
Oh, definitely. These pits, these potential cave entrances, they're becoming high-priority targets. You can bet future robotic missions will be designed with these in mind.
Like sending a rover that can actually go down into one?
Imagine that. A rover, or maybe even a specialized drone or climber equipped to explore inside. The potential payoff is enormous, finding preserved signs of past life, biosignatures.
Or maybe even finding something still living, like microbes.
That's the ultimate prize, isn't it? Finding extant life in a protected little niche, and thinking longer term about astronauts.
Yeah.
These caves, these lava tubes, they could actually serve as natural habitats. Ready-made radiation shelters, protection from micrometeorites, stable temperatures. It could solve huge problems for human bases.
Wow, using the planet's own features. And it's not just NASA thinking decades ahead, is it? There's SpaceX.
Right. Elon Musk and SpaceX have, let's say, a more aggressive timeline in mind.
Much more aggressive. Talking about uncrewed Starship tests maybe as soon as 2026, crew potentially by 2028. That feels incredibly close.
It's a very rapid projected timeline, yes. And while their main goal is settlement, those early missions, even the uncrewed ones, could be invaluable for studying these features.
How so?
Well, they could potentially deploy smaller probes near these pits, gather atmospheric data from inside, maybe map entrances with higher resolution, basically doing reconnaissance that helps everyone figure out which spots are most interesting.
So even their commercial push could help the scientific search?
Every bit of data helps piece together the puzzle of Mars' subsurface. Understanding these portals and what lies beneath is going to be crucial, whether for science or settlement.
So for everyone listening, just pause and think about that. This idea of a hidden world, maybe just beneath the dust on the planet right next door, does that change how you view the odds of finding life elsewhere? For me, it's kind of mind-bending. A whole potential biosphere just hiding.
It really challenges our assumptions, doesn't it?
Yeah.
Where life can be. We tend to think surface, sunlight, liquid water we can see.
Earth-like conditions.
But maybe life is way more adaptable.
Mm-hmm.
Maybe it finds refuge in places we haven't seriously considered, shielded from the obvious harshness. It suggests resilience.
Okay, so wrapping this up, our deep dive today, the big takeaway seems to be this. NASA highlighting this potential portal, plus all the evidence for these underground networks. It really strengthens the case for habitable zones beneath the Martian surface.
Right. It shifts the focus, makes the subsurface arguably one of the most promising places to look now.
It really recalibrates things.
Exactly. And that leaves us with a pretty profound thought, doesn't it? A question for everyone listening to mull over.
What's that?
If we do find life under the Martian soil, how does that change? Well, everything. Our understanding of life's origins, how common it might be in the universe.
Yeah, a whole hidden world next door.
The philosophical implications alone are huge.
Right.
It would suggest maybe the universe is just packed with life hidden away in unexpected corners. So yeah, keep watching the skies.
What do you think about this story?
And maybe keep
Comment
watching
your
the
thoughts.
ground beneath them
Thanks.
too. Feels like we're on the verge of some big answers.